Good morning, students. Let us solve problems on equilibrium of rigid bodies in two dimensions. Okay. So here we are under equilibrium analysis. That means the particle is not moving. The particle is at rest. So such type of problem we are going to solve. So first we try to solve this problem. So here first read the problem. An electric light fixture weighing 150 newtons hangs from a point C by two strings AC and BC as shown in the figure. Determine the forces on the strings AC and BC. So electric light is hanging here at the point C. So it hang by two strings BC and AC. Now the diagram is given in the question. So listen, that is it the bulb is moving? No, the bulb is not moving. Bulb is at rest. That means the resultant value is 0. So how to solve this? So here the bulb having weight 150. Weight means downward force, isn't it? The bulb is hanging downwards. It tries to fall down, but the light is not falling down because it is supported by the two cables. Cable means wire. Okay, thin wire. Two cables. It is not falling down. So here weight is acting. This weight is supported by two cables, by AB and BC. So when the light is pulling down, this tension act towards upward. It pulls up. Also BC also pulls up. So tension act in the reverse direction. So see this diagram. The weight act downwards. Tension acts upwards. It brings down, it brings up. So finally the resultant will be 0. That means it is in equilibrium. The bulb is not moving. At the point C there is no resultant force. So here we have three forces. One downward force, one upward force, two upward forces, two forces. So here we have three forces. So three forces means three forces in equilibrium. So we can use Lamis theorem to solve this problem. So, okay, it's very simple to solve. So for solving the Lamis theorem, we need the angles, right? Angle between the forces. So how to find from the given diagram? So listen. So this angle we know, we need to know the angle between the forces. For that, so see here this diagram 45 degree, right? This line is horizontal line. So draw here also one horizontal line. So this is horizontal line, this is also horizontal line. So this angle is 45 means this angle also 45 degree. So here you see here this angle is 60 degree. This is vertical line. So here also I draw one vertical line. So here vertical line, one crossing line. So when this angle is 60 degree, this angle also 60 degree. So from this we can find the other angles. So here this angle is 45, right? This angle is 45 degree. So what is this angle? This is horizontal line. This is vertical line. Between this, what is the angle? 90 degree. So sum of these two angles, 90 plus 45, 135 degree. Okay. Then this angle is 60 degree, isn't it? This angle is 60 degree. So if this angle is 45 degree, this angle also 45 degree, isn't it? So this is vertical line, horizontal line. Between this, the total angle is 90 degree. So as this angle is 45 degree, this angle also 45 degree. So 60 plus 45, between these two, it will get 105 degree. Then If this angle is 60 degree, what is this angle? 30 degree, isn't it? Because, so this is vertical line, this is horizontal line. Between this 90 degree. So this is 60 degree means 90 minus 60 becomes 30. 30 plus 60 becomes 90. So okay, then this angle is 90 degree. Horizontal, vertical. So 90 degree. 90 plus 30, 120 degree. So we got all the angles. Then Lamis theorem states that Lamis theorem TBC, okay, TBC divided by sine of angle between other two forces. So totally here 3 forces. So I am considering for this force. Other 2 force means these 2. Angle between the other 2 forces 135 degree. That's all. This force divided by sine of angle between other 2 forces. So this force, other 2 forces between this 135 degree. The next is TAC. Angle between other 2 forces is 120 degree. Then equal to 150 divided by angle between other 2 forces 105 degree. So we can use this relation. Then equate these two first. Okay, these two first. TBC by sine 35 is equal to 150 divided by 105. Now we need to find TBC. So TBC, so bring this sine 135 to the right hand side. Then we will get the value of TBC as 109.81 Newton. Then equate this value and last one. So when equating this, we will get the value of TAC. Value as 134 Newton. So we got the value of tension in the 2 cables. Okay. Let us solve another problem. So here this problem also we can solve by using Lamis theorem. So here, let's read the problem. A smooth sphere of weight W. So weight is not given in the question. Weight W is supported by a string fastened to a point A on the smooth vertical wall. The other end is in contact with the point B on the wall as shown in figure. So okay, a smooth sphere or round sphere is fastened at point A by a string. By a string, it is fastened at point A, and it is in contact with this wall, vertical wall also, vertical wall at the point B on the wall as shown in figure. If the length of the string AC is R, so this radius is R, this length also R, it is given in the question. Length of the AC is also radius R. Find the tension in the string and the reaction on the wall. So okay, first we have to understand what are the forces acting on this. So here one wall, one string, one sphere. So here spring, the sphere weight is acting towards downward, isn't it? Weight is acting towards downwards. So as the weight is acting, the sphere try to fall downwards, but it is not falling down. Why? Because means it is supported by this cable, supported by the cable. So this downward force is supported by the cable. So actually this is not only supported by the cable, because it is hitting on this wall. Okay, hitting on this wall also. So wall also support this weight. So how it is supporting means, when the wall is supporting on, when the wall is in contact, when the sphere is in contact with the wall, what happens? It experiences a force, isn't it? The ball experiences a force on the wall. So at the same time, the wall gives one opposing reaction. Okay, this is reaction RB. Reaction RB, which is perpendicular to the surface. Okay, the reaction force is acting perpendicular to the surface from which the reaction is created. Okay, so reaction. So here we understand another word, reaction. Reaction means whenever an action is restricted, reaction force is created. So here action means the sphere try to move the wall towards left hand side, but the wall is stationary, right? It is fixed. So wall gives opposing reaction. Action force is restricted, so reaction force is created at the contact. Whenever a contact is there, reaction force will be created. Okay, when a weight is acting towards downwards, tension force acting towards upward. So as it is in contact with the wall, the contact surface, at the contact surface, one reaction force is created. That reaction force is perpendicular to the wall. So here we have three forces: one weight, one reaction force, one tension. So now we need to find, so three forces. So here this force is acting towards the point. So I draw as acting away from the point. That is same, towards the point. I transfer like that. Principle of transmissibility of forces, right? So by that I can draw like that. Now we have three forces and is in equilibrium. So now we can use Lamis theorem to solve this. So in order to solve by Lamis theorem, we need the included angles, right? Included angles. So how to find the angle between the forces? Just listen. So here they are giving that this value is R, right? Length of the cable AC is R. So this value is R. So this value also radius, right? R. So here draw this line. This value also R. So here R. So totally 2R. So here 1R. This angle, assume this angle as theta. So how to find the angle theta? So this value is R. This also radius. This value also radius 2R. So here we can use adjacent side and hypotenuse, we know. So we can use cos theta. Cos theta means adjacent side by hypotenuse. Adjacent side is R, hypotenuse is 2R. So theta is equal to cos inverse of this. We will get the angle as 60 degree. So this angle is 60 degree. So this angle is 60 degree. So here, come to here, this angle. What is this angle? This angle 90 degree, right? So this angle is 60 degree. This angle 90 degree. So this angle is 90 degree. This angle 90 plus 60, 150 degree. So 90 and 150. And after that, this angle. What is this angle? Up to this 90 degree. So here 30, 90 plus 30, the value is 120 degree. So now we can use Lamis theorem. So we know that Lamis theorem is equal to each force TAC, angle between other two forces, sin alpha, RB 150, W by 120. So here equate these two. So we will get the relation as. So the value of W is not given. So just put as W. Then equate these two. We will get the value of RB in terms of W. So tension in the string is the value 1.155 W and the reaction in the wall is 0.577 W. So by this we found the reaction value and the tension in the cable.